right, so just like the pressure on a gas can indicate to us the molarity of the gas that will dissolve in a liquid, there are other units of concentration that are helpful in describing how the concentration or the boiling point or the freezing point of compounds will change based on their mixing with other chemicals. Okay? So what that requires us to do is become familiar with other ways of expressing concentration. Right? So we are familiar with molarity, and in class or in lab, if you took lab recently or remember, we have talked about percent by mass. Okay? And we also talked about mole fraction, even though we'll review it again. But molality is another one that we haven't introduced or talked about. So we're going to go through these and kind of understand them. There's another set over here for lower concentration, and really from this one, it's parts per million that we're really only going to talk about ever. But let's review these concentrations and introduce new ways of expressing concentration in the case of molality and maybe mole fraction and percent by mass, depending on your background. But again, why are we introducing these? Because different characteristics of materials or solutions change according to these different ways of expressing concentration. So we have to be familiar with them. Molarity, moles of solute per liter of solution. Hopefully that is one that we can work from and understand what that means. The big deal about molarity is remembering that it's not liters of solvent. It's liters of solution. And just in case it's been a long time for somebody out there, remember that when we are making a solution, what we're doing is we're mixing a solvent, right, with a solute. So we put the solute in, and the solute dissolves into the solvent. The solute dissolving into the solvent, you know, our typical scenario that we would use as an example is something like sodium chloride and water, all right? But this isn't the only kind of solution that can exist. Air is an example of a common solution that people sometimes draw on to talk about to make sure people kind of have a more fundamental understanding of solutions. Air is a mixture of nitrogen, oxygen, and a little tiny bit of carbon dioxide. Let's see, I think it's Aisha's turn. So Aisha, if you think about air as a solution, a mixture of a solvent with some solutes. Now let's see if you remember, Aisha, what's the difference between the solute and the solvent? What would our solvent be in the case of air, Aisha? The solvent in the case of air. So air is a mixture of different gases. The solvent, what makes something the solvent in a mixture? Do you remember that, Aisha?
It's in liquid phase, but I don't know what's the solvent. Yeah.
Okay, so the solvent doesn't necessarily need to be the one in the liquid phase. It's just the thing that's in the greatest amount. So the solvent is in the greatest amount. I don't know, does that help when you think about air? What's in the greatest amount when we're talking about air as a solution?
Would that be nitrogen?
That's right, nitrogen gas, because nitrogen gas is about 80% in the air, with oxygen gas being almost the rest, which is about 20%. Okay, very good. So, solutions, solute, solvent, a little bit of a review there. And now molarity is moles of solute per liter of solution. Whereas this new term, molality, and it's an M, a lowercase m, and oftentimes they'll underline that lowercase m to kind of differentiate it from meters. Okay? It's moles of solute, just like molarity is, but it's kilograms per moles of solute per kilograms of solvent. Okay? All right. It doesn't seem to be a very friendly way of expressing concentration, but it turns out to be the way that you relate certain parameters, boiling point or freezing point, for example, are expressed in terms of molality. Mole fraction. Mole fraction is the same as saying something like 50%, or like we just said here, this is a better example, 80% nitrogen, 20% oxygen in the total. This is not mole fraction, this would be mole percent. Mole percent. But when we talk about mole fraction, instead of saying 80%, we would say 0.8 and 0.2 for their mole fractions. All right, so there could be molar percent, and then there would be mole fractions. The sum of the mole fraction always adds up to 1. Right? The sum of all of the fractions when you're talking about a complete whole will always add up to just 1. Okay? And then there's percent by mass, where we're talking about the mass of the solute over mass of solution, where we're thinking about 100 grams. So mass of solute over 100 grams of solution. Okay? All right, percent by mass. This is mass solution here. It's not volume of solution. Now, sometimes when the density of a solution is 1, right? Density. Can you remind us, Landon, what are the units for density when we're talking about a liquid or solution? What are the units that we usually use? You there, Landon? What are the units that we usually use for density?
I know density is mass over volume.
Good. Mass over volume. So what's an example of mass? What kind of unit would we use for mass?
We could do grams or kilograms.
All right. So for liquids, we usually use grams per. Do you remember any? Usually for density.
Yeah. Liters.
Usually it's milliliters.
Or milliliters. Yeah.
For liquids, right? Density for gases is usually grams per liter because you need a lot of gas to get a reasonable amount of mass, right? But whatever your units are, mass over volume is all really what you need to remember. But the reason why we say that oftentimes the mass of the solution might be similar to the volume of the solution is because the density of water, do you remember what the density of water is, Landon?
Isn't it the standard 1?
It's 1. It's not a standard. It just happens to be 1. Well, I guess you could call it a standard because that's what we've defined as a milliliter, 1 gram of water. So yeah, 1 gram per milliliter. Now that density changes with what's it called? Temperature. But if it's mostly water, then your density will generally be 1 gram per milliliter. All right, so parts per million we'll have just a short conversation about. Because we have introduced it before, we had it in lab, but it is probably easiest just to memorize that it's milligrams of solute per liter of solution, milligrams of solute per liter of solution. All right. If you already knew that, but you don't remember why that makes any sense, I'll explain to you right now why it makes sense, and you might be able to digest it and understand. I've done this once in lab, but again, I know that it's not easy to digest, but you might get it this time, and if you don't care to get it, then you can just fast forward it over this part or whatever. But when we're talking about parts per million, that's pretty clear. The language is saying how many of all the million parts are your solute that you're interested in, right? If I say I have 10 parts per million, right? Well, we just said that that means 10 milligrams for every liter of solution, right? 10 parts per million means 10 milligrams for every liter. Well, if I take 1 liter, that's the same as 1,000 milliliters. So 10 milligrams for 1,000 milliliters is the same as 10 parts per million. Now, we just also identified that 1 milliliter had a mass of 1 gram, right? Density of water, or solutions that are mostly water, right, is 1 gram for every 1 milliliter. So 1,000 milliliters is similar, or going to be essentially equal to 1,000 grams if the density is close to 1. So that's 10 milligrams for every 1,000 grams. And if I take my 10 milligrams and put it over not 1,000 grams, but convert this to milligrams, that's 3 more zeros, milligrams. So now you can see how when they're in, oops, not milliliters, milligrams. So now we can see how when they're in the same unit, it's 10 out of every million parts, right? So this is 10 parts per million.
How are the milliliters and the grams the same? Like, why are they both the top?
Okay, so for water or any solutions that are fairly dilute, because when the solution is dilute and the solvent is water, then the density of the solution is going to be pretty much the same as that of water. So what we're basically saying is that for every 1 gram of the material you have, if it's water or if it's anything that's really dilute like water, then it's going to be a milliliter of volume. All right. So the density of water is 1 gram for every milliliter. Or in other words, 1 milliliter of material has a mass of 1 gram. All right. And that's also in this slide here where it says when the solvent is water, the density is going to be close to 1 gram per milliliter for these very dilute solutions, very low concentrations. Thus, parts per million is equal to milligrams per, or sorry, for parts per million, you could say micrograms per gram or milligram per 1,000 grams, which is a liter. Did that make sense? Was that Camille that asked that question?
Yes, thank you, sir.
All right. Excellent. So, we're going to go and try to do some calculations now where we identify the molarity, molality, mass percent, parts per million. Is that it? Molarity, molality, mass percent, parts per million, and then mole fraction. Mole fraction. Okay? We're going to do some problems where we actually do these calculations. And to help us, we have a little kind of a spreadsheet here, maybe. You wouldn't need to do this if you were actually answering the question, because you will have done it many times in class, or enough times, that you can see why we do it and what we're trying to get at. And so you don't need to, but you're welcome to. It might look daunting and say, oh, I'm not going to remember how to set up that table, let alone fill it up after I have it set up. But you'll see what this is, and you won't need every single number to answer every single question. But what this does is it just allows us to organize our thoughts, especially in introducing molality and these other factors. Okay, so what does molarity tell us? So here's a question. What is this M here? Whose turn is it? Leata. What is this M here? Little m.
Molality.
Molality. That's right, molality. Now, can you remember, Leata, what molality means? Or sorry, molality means?
Moles of solute
Moles of solute per.
kilogram of solvent.
Very good. Moles of solute, kilograms of solvent. All right. X. Camille, what is X?
I know I should know, but I don't.
Oh, I skipped Taiwan. Taiwan, what is X? Do you remember X, Taiwan? You there, Taiwan? What is X? Okay. X is mole fraction. Mole fraction. So it's trying to identify the moles of solute over total moles. Total moles, right? Okay, percentage. What is percentage talking about here, Sarah?
Is that mass of solute over mass of solution, so percent by mass?
That's right. Mass of solute for every 100 grams of solution. And that's what gives us our percentage. Very good. Alyssa, what is parts per million? How are we going to remember parts per million?
Milligrams of solute over liters of solution.
All right. Very good. Excellent. So, we want to identify molality, mole fraction, mass percent, and parts per million, having given the information of one molarity, one molar solution, KCl. All right? And then we're also provided the density here. So we can start filling up these holes, and then once we have them filled, it's really easy to go here and answer these questions. Now, Leata said that molality was moles of solute. So we want to get, here is our solute, KCl. We want to know how many moles there are and divide it by, molality was moles of solute per kilogram of solvent. So our solvent here is water. So we just want the mass of the solvent here. So those are the two we need for this problem. I think first to get to molality. Moles of solute and kilograms of solvent. All right. So from knowing that we have a 1 molar solution, which of these boxes, can you see any of these boxes? Let's see, where did I leave off? I think it was Robert's turn. Robert, which one of these boxes here can we fill in with this information? 1 molar KCl.
So we have, I'm not really sure, but I know that we're using the moles of the solute and the liters of the solution. So working with the solute of KCl and then over with the solution. So I'm going to guess the moles and solute KCl, we're going to be filling that in.
All right. Yeah, we're going to put a 1 here for moles of solute, because that's what the 1 molar tells us. And we know our solution volume is 1 liter.
1 liter. Okay.
Good. So once we've filled those in, we can begin to fill in other things. For example, we can fill in the mass of KCl that we have in this 1 molar solution. Now, we've also kind of identified the volume for our model here that we're working with. So from this, I can tell that in my solution, and I'll draw it here to the right to make those who are uncomfortable with this problem maybe more comfortable, This is the volume of solution we're talking about. This is 1 liter of this solution, and it's 1 molar KCl, right? Okay, there it is. I can even put a little glare in here so that you can tell it's in a bottle, right? Not much better. Okay, good. So we got our bottle here, 1 mole of solute, 1 liter of solution. There it is. I can know what mass of KCl I have in this system right here because I know I have 1 mole of it, right? Landon, what mass do I have in here? What mass, if I have 1 mole, how many grams of KCl?
Hang on one sec, I gotta pull up a periodic table.
Well, I got it right here for you. Do you see this right here?
Oh, no, I did not see that.
All right.
It's 74.
Yeah, this is 74.55 grams per mole. We got 1 mole, so there's 74.55 grams. Okay, very good.
Okay.
Now, once I have the mass of my KCl, right, I can determine the mass of the total solution, or the total, this whole thing right here. How can I, what do you think, Aisha? How can I find out what the mass of this total solution is? The mass of the total solution. I have the density here. It says 0.99 grams for every milliliters. And I know that I have 1 liter. Can that help us identify how much mass this whole solution is, Aisha?
Yes.
What can I do? What do I have to do?
So we're starting with the density, right?
Okay.
And then convert the 0.99 grams per every milliliter.
All right.
And then for every 1,000 milliliters, there's 1 liter.
All right. 1,000 milliliters in every 1 liter. Now, I'm looking for a total mass of the total solution here. And I know I have 1 liter of my material. Is that how we would do that? So
Yeah.
liters goes away, milliliters goes away, and I'm left in grams. Mass, so this is going to be in grams, of my total solution. And that looks like it's going to be 0.99 times 1,000, or 990. Is that true? So I have 990 grams of my solution. 990 grams of my solution. All right, good job, Aisha. Now, Leata, back to the beginning here. What are my 2 boxes that I need to get molality? What are the 2 boxes I need to get molality? I need what?
Sorry.
Any ideas? What is molality again, Leata?
It is loss of solute per unit solute.
Per what?
Kilograms of solvent.
That's right, kilograms of solvent. So I need my moles of solute here, and then I need to get grams right here, right, of solvent. Grams of solvent. Okay, this 990 is the mass of the total solution. That mass comes from the KCl and from the water, the solute and the solvent. This is the mass of the KCl. And so, can you think of a way, Taewan, that I can find the mass of the water that's in this solution? Any ideas, Taewan?
Yeah, the total solution of KCl is 990. So when you subtract the KCl,
That's
yeah, and you come out the mass of
That's right. I have the mass of the total solution, which I know is made up of the grams of solute and the grams of water. So I can take my 990, subtract 74.55, and then I'll get the mass of my water in grams. Very good. Now, from these two boxes here, I can solve for my molality. Camille, are you ready to solve for the molality here?
Yes, sir.
All right, why don't you do it for us? What's the molality?
Okay. Molality is moles per solute over grams per solute, so
Over
there's one-
kilograms of solvent.
Oh, yeah.
Kilograms.
So 1 mole over. Oh, then the 9.91.915.44 goes to 0.91.
That's right. Very good.
1.09227.
All right. Very good. So that is our molality. Excellent. Now, mole fraction. Mole fraction. To get mole fraction, what do I need to get? Let's see, whose turn is it? Sarah. What do I need to do to get mole fraction, Sarah?
So you need to take the moles of, like, how many moles you have of solute, I believe. Solute divided by the total moles in the solution.
Very good. Very good. Where can I get the total moles of solution? Total moles. Well, I need to add up the moles of solute plus the moles of solvent. And that would give me the total moles in solution. I know how many grams of water I have there, and I can convert this grams of water into moles of water. Do you think you can do that for us, Sarah? Can you convert the 915.44 grams of water into moles of water?
Yes. So you just divide 915 by 18 grams.
Mm-hmm. Very good. And what does that give us? The moles. Yeah, the 50.8 moles of solvent. Now I have moles of solute and moles of solvent. Again, we're just talking about our little model here, which is the 1 liter of our solution, right? And I can add those two together. So I'm just going to take this value here, add 1, and that's going to be my moles of solution. All right, very good. Now, do you think, Sarah, you can finish identifying what the mole fraction is here? How would we find the mole fraction from this information?
Yes, so you would divide, or you would do 1 divided by 51.8.
Very good. So the 0.019, right? Is that what we got? Would be our mole fraction. All right, so we got 1.1 for the molality, 0.019 for the mole fraction. We have all our numbers here, right? So we should be able to find them all. Alyssa, your turn. What values do we need from this table down here to find the mass percent?
We need the mass of the solute and the mass of the solution.
All right. Mass of the solute, 74.55. What's the mass of the solution?
990.
Divided by 990. Does that make sense? 0.075.
Guess that would be 7.5%.
Okay, that's right. And then we have to multiply it by 100, right? Very good. So 7.5%. Very good. So again, it's mass of solute over every 100 grams of solution. Or you could do mass of solute over the mass of solution that you have and then multiply by 100. Very good. Parts per million. Who's up? Robert. Parts per million. What can we do here?
So take the we're gonna go from grams of RKCl,
Okay.
and well, I mean, in the end results, we need grams of our KCl and then have milliliters for our solution.
Was that what parts per million was? Grams per milliliter?
I believe so.
Let's go back to this previous slide here and see what it was. So parts per million are either micrograms of solute per milliliter of solution or milligrams of solute
Milligrams
per liter
per liter.
of solution. All right.
Okay.
So milligrams of solute per liter of solution. What values is that can we use to get us there?
Sorry, just to clarify, it was what per milliliters?
It was milligrams of solvent. Here, I'll write it down. So it was our milligrams of solvent. No, sorry. Solute. Milligrams of solute per liter of solution.
Per liter of solution, okay. Okay, so just with the one for our solute, that is the number of moles we have. But for as far as grams, we have 74.55 grams. So we need to convert that to milligrams.
Mm-hmm. Divide by 1,000, multiply by 1,000. What do we do?
2 milligrams. We would be dividing it by 1,000. Okay, so we have the milligrams, and then as far as liters, we have it in liters, correct? Of our solution. Well,
That's right. That's right. No, you're right.
So it'd just be the 990 liters.
No, because that's this 990 here is grams of this solution.
Oh,
right?
okay. Yeah. Okay, totally see. Okay, so our solution volume is just going to be the 1 liter.
Yeah, it's already 1 liter. That's right.
Okay, so then we're going to have 0.075 parts per million.
Okay. I think, yeah. Okay, let's double check here. Let's look real quick. If we have 74.55 grams of solute, which is KCl here, and we want to know how many milligrams of KCl, right?
Yeah, so...
Grams goes down here. Milligrams goes... Oops. Grams go down here. Milligrams go down here. What's our relationship then?
Okay, so we got to multiply it by 1,000.
Yeah. Okay, so 74.55 times 1,000, and then divide by 1. So our
74,550.
Very good.
My bad.
That's fine. So our parts per million is 7.5 times 10 to the 4th. Okay. Excellent work. Now, let's do it again. Molality is provided for us. We have a 1 molal solution of KCl, and we would like to identify the molarity, mole fraction, mass percent, and parts per million of this solution. So, let's see, Landon, if we start off with molarity, which of these, if we start off with molality, which of these boxes will we know, or what information do we know right away? Any ideas, Landon?
Yeah. So we have 1 molality of KCl, which is moles of solute over kilograms of the solvent. So would we... Oh, we would know the mass.
Mass of what?
mass of KCl.
Well, okay, so you said molality, little m, is moles of solute over,
Kilograms of solvent.
whoops, a little too small there. Come on, baby. Kilograms of solvent. And you said we would know the mass of the KCl. I think you skipped up ahead. You're right. We would know it pretty quickly. But just right at the beginning here, this is telling us that we have 1 mole of solute and 1 kilogram or 1,000 grams of solution solvent. Is that right? So those are the two we can fill in right away, right? Does that make sense?
Yeah, that makes sense.
But you went on and said that we can know the mass of the KCl. How do we know the mass of the KCl now?
I was thinking because we know that it is 1 mole of KCl, then we would know that it is also the same mass.
Yeah, so what is the mass of KCl in this situation?
74.5510.
Very good. Now, I'm going to help us recognize, here it is, right? It's my container of solution, and what I know is that it's 1 molal, or that there's 1 mole of KCl and 1 kilogram of water, right? And that's what I know about this situation here. And that's what we're describing and fixing our kind of our system, and knowing what we're talking about is important. So can we identify the moles of solvent here? Let's see, Aisha, how many moles of solvent? How would we determine how many moles of solvent we have?
Use the molar mass and the grams of solute.
All right, so we would take our 1,000 and divide it by what?
Oh, right. Divide by 18.
18.0153. Very good. So we got 55.5 moles of solvent. Very good. Now, molarity means we need what? What do we need to solve for molarity, Aisha? That's right. Moles of solute, which we have per liter of what? Solution. So do we know the solution's volume here? Is this 1 liter? Do we have 1 liter here? Do we know, or do we have to do a calculation? What do you think, Aisha?
We need to calculate it.
Yeah, we do, don't we? We're not told that we have 1 liter. We're just told that we have 1 mole of KCl and 1 kilogram of water. So maybe we should identify the total mass of the solution, and then we can use the density to get the total volume of the solution. What's the total mass of solution, Aisha? How would we find that here?
Just the sum of the two masses.
That's right. The sum of the solute and the mass of the solute, and the sum with the mass of the solvent. Very good. All right. Now with this 1,074.55, how can we identify what the volume? And let's say we want it in milliliters, just for fun. It could be in liters. But what is the volume of our solution going to be? How can we solve for our volume of our solution now?
We start with.
Yeah.
Oh, okay.
Go ahead. What is it, Aisha?
We start with the density.
The density, which is 0.9
0.9.
grams per milliliter. And then what?
And then for every.
Did we do it wrong?
Which one? It's because
Let's try that again. Did I write that wrong? We want milliliters on top, right? Is that true? Because I have here 1074.55. What are the units for that 1074.55, Aisha?
grams.
Grams, that's right. So 1074.55 grams will cancel out, and then I'll be left with milliliters there. Okay? So 1096.47. So that's our mass of solution. Sorry, that's our volume of solution. Now, we also got our moles of solution. Where can we get our moles of solution, Taewon? What does that mean? Where are we going to get that?
Some of one more of water.
That's right.
And then over
It's just the sum of these two different moles. That's how I get my moles total. And then my mole fraction I get by taking the 1 over the total for my KCl, right? All right. So, Camille, why don't you tell us what the molarity of the solution is? What's the molarity of this solution? We were told the molality was 1, and now we're going to be able to solve for the molarity. What is it?
Molarity is grams per liter, correct?
No. What does molarity mean? Big M.
I thought it was moles per liter.
You thought it was what?
Oh, wait, per liter.
No. Well, you just said grams per liter, but I think you're thinking moles, because that's why it's called. Yeah, moles of solute for every liter of solution. Okay, very good. So,
1 divided by 56.1.56.
is that the volume of solution?
No, volume. Oh, 1096.
Yeah, 1.096 liters of solution. So this is 1 mole of KCl. What's that?
Which is 0.9124.
All right, very good. 0.091 molar KCl. All right, mole fraction, Sarah?
Yes, so that is. So you have to leave 1 divided by 56.1.
Did you say 1 divided by 56.1?
Yes.
That's right. So 0.017 would be our mole fraction. I guess 0.018 when we rounded up 1. All right, mole fraction. Very good. Sarah, do you want to give us our mass percent as well? Or did you do mass percent last time? I feel like you did mass percent last time. I know. Well, go for it, Sarah. Mass percent.
Okay, so that would be. So the mass of a solute, which is 74.55 divided by. So 74.55 divided by 1074.55.
Is it the 0.069? Is that right?
Yes.
Or do I have to multiply that by 100?
Oh, right, yes.
Yeah. Okay.
So
6.9%. Excellent. Thank you. So, Alyssa, how about the parts per million? Can we do that one?
Yes, I can. So I have to do the milligrams of solute. So you have to multiply that by 1,000. So it'll be 0, and then you divide it by the liters of solution. So divided by 1.096, and then I got 68,020 val.
Okay, very good. Or 6.8 times 10 to the fourth, probably, yeah. Excellent. Very good. So in that case, from the molality, we were able to get molarity, mole fraction, mass percent, parts per million. Okay, here we are. We've been given a mole fraction of 0.06. 0.06, can we identify the molarity, molality, mass percent, and parts per million from mole fraction of 0.06? All right, Robert. What are the things, what are the parameters here in this box that we have when we're told that we have 0.06 as a mole fraction?
So, with the moles of the solution, and then we have the total, that's going to be over the total moles. So it'd be, wouldn't it be the moles of the solute over the moles of the solution?
That's right. That's right.
Okay.
Moles of solute
Okay.
over moles of solution. So what are we going to put in here for moles of solute?
That's going to be just the number of moles. Okay, I'm going to guess the 0.060.
That's right.
Over the 1. Oh, okay, that makes sense. Yeah, I got you.
All right, very good. Now from this, what can we do? How can we proceed, Robert? Why don't you tell us one more box?
Yeah, so we can figure out the mass of the KCl.
Okay, what would we do here? What values would we multiply? Or what would we do?
So we do the 0.06. You'd either take the 0.06 divided by 74 or do the 74 divided by the 0.06.
That's a really great question. Let's figure that out. We want, what do we want? What are we after?
So we're looking for the mass.
Right.
Is the
grams.
density.
Grams of KCl, right?
Correct.
And 0.060, what are its units? 0.060.
Those are moles.
That's right. That's right. 0.06 moles of KCl, right? It's mole fraction. All right. So what do I got to do here? Yeah, go ahead.
Are the reference, are those always constant? 4.55?
Oh, this here, this is just for KCl, right? And we've been dealing with lots of solutions of KCl, and this is the molar mass for water.
Oh, okay. Thank you.
So what we're going to do is we need the moles to cancel. So we have, for every 1 mole, we have 74.5510 grams.
All right. So we have to multiply them, don't we?
Correct.
Okay. So 0.06 times our 74.55, and that gives us 4.473, and that's grams of KCl, right?
Right.
Excellent. Very good. Landon, then, what can we fill in next? Which box can we fill in next?
We could figure out the moles of the solvent H2O by subtracting 1 and 0.60.
All right. So 0.94 is our mole fraction of what? Of the water, correct?
Yeah, the H2O.
Very good. Now, Landon, can we get the grams of water from that information?
I think so, yeah.
How would we do it?
Well, we know that we have 18.01 grams for every mole, and we have 0.94 moles.
Let's write it out.
Moles. Excuse me, where do we get the 0.94 moles for water?
That is the mole fraction of the water. In this solution, all we had was KCl and water. So the total mole fraction is 1, and so 0.06 was given to us as the KCl.
Okay.
So the
Yeah, I
rest
see now.
had to be 0.94. So it's basically 1 minus the 0.06.
Yeah, I see it now. Thank you.
Mm-hmm. So the 0.94, that's a good question. So 0.94 moles, how do we get that to grams of water, Landon? What do we got to do here?
We use the conversion factor. So we put 1 mole on the bottom, and on the top you're doing 1 mole of H2O, and then on the top you're doing the grams, and then you multiply 18.0153 by 0.94, and you get 16.934.
All right, so that's our mass of water. And Landon, while you're here, tell me, how can we get mass of solution?
You add the mass of the solute and the mass of the solvent.
Very good. Excellent. Harry, are you ready to contribute in the talking realm now?
Yeah, sure.
Okay, so tell us, how are we going to get our solution volume?
The solution volume, so you have the mass of the solution.
We do, 21.403 grams, yeah.
So you use that with the density to get the volume.
So do I multiply it or divide it? What do I do?
Hang on a second, let's see.
I want the volume of solution, so let's say milliliters of our solution.
You would divide it.
Okay, so I take 21.43, that's going to be in grams, and I need grams to be gotten rid of, so I need milliliters up here. So what numbers do I put in here?
0.87 grams over 1 milliliter.
Well, yes, or 1 milliliter is 0.87 grams. I knew I needed grams on the
Right.
bottom because of that. Very good. So 21.43 divided by 0.87.
I think it's 403.
21.403. Very good. Thank you. 24.6 about then, or 0.0246 liters. Okay, very good. So, from that information, who's up? Aisha, can you tell us what the molarity of our solution must be? What's the molarity of our solution? What numbers do we need to use to get the molarity here?
The moles of solute 0.0246 liters.
Okay, moles of solute, which is what, 0.06, is that right?
Yes.
And
Or
over 0.0246 liters. Okay, so 0.06 divided by 0.0246. 2.43, did I do that right?
Yes.
Okay, good. 2.4 molar. Thank you. Taiwan, what do I got to do to get molality? What do I got to do to get molality, Taiwan? Molality. Little m.
Moles of solute
Mm-hmm.
over kilograms of solvent.
Very good. What are our moles of solute again? Very good. What are our kilograms of solvent?
Oh.
16 is not kilograms. It's in grams, though, right? But that's right. We're going to use this 16 to make it kilograms. What do I got to do to make it kilograms?
So point zero, point 0.16.
Very good. All right. So our moles of solute, 0.06, divided by kilograms of solvent, 0.01693. All right, 3.5 molal. Very good. Camille, what do you think? What's our mass percent?
Times that by 100.
Times the molality by 100?
Yes. Wait, no, that's wrong. I'm honestly actually.
Okay, so mass percent is grams of what? What is it, Camille? Grams of solute, very good, over grams of solution, and then that is times what?
100.
Yeah, times 100. All right. Where do we get those values? Where's our grams of solute?
4.473.
Okay. And where's our grams of solution?
16.93.
16.9. Oh, wait. Hold on just a second. This is grams of solvent, though, right? We want grams of solute divided by grams of solution. I might have said solvent, but we want grams of solution. All right, so divided by 21.403. Is that it?
Okay, 20.8%.
Yeah, times 100. Very good. 20.8 or 21%. Excellent. Okay, Sarah, can you get us our parts per million?
Yeah, so parts per million is milligrams of solute, which would be 4,473. And that is divided by the liters of solution, which is 0.024.
Good. So, looks like 1.8 times 10 to the 5th. Excellent. Very good. Do we have one more in us? Well, we're going to do it anyway. Okay. Alyssa, you're here to help us. First off, what information do we get from the problem that's provided? This time they're giving us a mass percent solution. Mass percent. So what do we got, Alyssa, to start with?
So, well, if we have the mass percentage of that, then we know we can like break it down, kind of. So I'm guessing we can make it. Do we just want to make it out of like 100 grams, or do I?
Yeah, that sounds good. Yeah. So which boxes can I fill in, and what values are we going to use?
So we could put 100 grams in the mass of the solution,
Okay.
and then
1.05 grams of the KCl.
yes.
All right. Excellent. And so what's the easy one to get right off the bat then?
It'd be really easy to get the mass of the solvent just by subtracting 1.05 from 100.
Yeah, that's right. So 100 minus the 1.05 tells us that we have 98.95 grams of water. Very good. I bet that the slide, though, identifies the moles of KCl first. How would we do that, Robert?
Nice. So let me draw this out. We're gonna have 1.05 grams, and we want moles. So we're gonna use. So there's 1.05 grams of KCl. So we're gonna put the molar mass on the bottom. So 74.55 grams per 1 mole on top. So we're gonna do 1.05 divided by 74.55, and so 0.0141 would be our moles of KCl.
Excellent. Very good. And now we talked about our mole or our grams of solvent. From that, Landon, how would we get our moles of solvent?
We do it the same way we got the moles of KCl, so we'd have 98.9 grams of H2O, and ultimately you're dividing it by, or no, wait.
Should we write it out so we don't confuse ourselves? We want moles of water, is that right?
Yeah, no, okay, yeah, I was just overthinking it. I was thinking we were going to have a different number for a solution. But, yeah, so you can do 98.95, and you're dividing it by, the grams of H2O, which is, hang on 1 second, 98.95 divided by 18.0153, 5.49.
All right.
Yeah.
Excellent. Very good. And now that we're there, Landon, it also would be really easy to find what value at this point?
The solution for moles.
Yeah, total moles. We're just going to take this
Moles.
5.49, which is moles of solution, right? Moles in that solution. 5.49, and then what do we do with it?
You're adding it to the moles of KCl, which is 0.0140843.
Very good. So we got 5.5 moles total altogether. All right, Harry, are you going to help us find solution volume? I feel like you did this last time. We're in a
Same thing as before.
we're in a loop. All right, what do we got to do then?
You divide the mass by the density, which is 1.15 grams per milliliter.
So there's 1.15 grams for every milliliter, and we want milliliters, and we start with 100 grams of solution. Okay. 86.95 milliliters of solution. All right, so Aisha, you're going to tell us the molarity. Taewan is going to tell us the molality. Camille's going to tell us the mole fraction. And Sarah is going to give us parts per million. Is that the exact same thing we just did? I don't know. Let's try it anyways. All right, Aisha, what's the molarity?
Is it 12.08?
You took the moles, which was 0.014, and divided it by what?
No, I didn't.
Okay.
I think I took the wrong.
Robert, you got lots of noise going on there.
Sorry. My bad.
All right, so we got 0.014 moles. And then what'd you do, Aisha?
Divided by 0.0869.
869. Very good. So about 1.161 molar, is that right?
Yes.
Let's see here. Okay. Very good. Taewan, did you get the molality? You're our molality expert, Taewon. What is it? Point 0.05? Mm-hmm.
0.09895.
9895. Did I do that right?
Yeah.
Okay, so 0.014 divided by 0.09895. All right, there we go. So we got 0.14 molal. Okay, Camille, what's the mole fraction?
0.014 over 5.5.
All right, 0.014 divided by,
5.5, which is 0.0025.
okay, very good. 0.0025. And then Sarah, our parts per million.
Yeah, so that's 1,050 divided by 0.0869, which is 12,082.
Excellent. Okay, very good. So now hopefully what you can see is why we have this box. Hopefully you can recognize that when we have a question like this, it's not going to be what's the molarity, molality, mole fraction in parts per million. They're just going to say if I have a 1.05%, what's the molality or what's the molarity? Just one of them, right? So you're not going to need to regurgitate this whole box. But what the box would do for you is allow you to hold still, take a breath, and just identify what you need. So for molality, I need moles of solute and kilograms of solution, right? Or sorry, kilograms of solvent. So if I knew I needed molality, then I could sit still and look at what it means to be 1.05% KCl and gradually tease out the kilograms of solvent and the moles of solute. Okay, for example. All right. Yeah, so get some practice working on the on the problems and figuring out how to go between molarity, molality, mole percent, parts per million, mole fraction, sorry, mass percent, mole fraction in parts per million. All right, so that's it for today. We'll meet again on Monday. The exam is open.